This is the engine that almost killed Rolls-Royce. And the wild part? It just came back. Stronger, quieter. With a fleet rollout so aggressive, the company is basically replacing every single one of its 787 engines currently in the sky. You probably didn't hear about it, because the headlines about the Boeing 787 always go to the same places: battery fires, quality scares, production problems. But underneath all that noise, something massive happened to the Dreamliner in late 2025 and early 2026. Something that flips the script on what people thought they knew about this airplane. The new engine standard powering the next generation of 787s, and slowly being retrofitted into the entire global fleet, is called the Trent 1000 XE. And almost everything you've heard about the 787's engines is wrong. So today we're doing something a little different. I'm going to walk you through the most repeated myths about the Boeing 787's engines and what actually happened with this upgrade. Some of them are going to surprise you. One or two might genuinely change how you see this airplane. Stick with me. By the end, you'll know more about the Trent 1000 XE than most aviation reporters. Myth number 1. The Trent 1000 has always been a fantastic, reliable engine. Yeah. No. Not even close. The truth is, the Trent 1000 went through one of the most expensive durability crises in the modern history of commercial aviation. We're talking corrosion-related fatigue cracking on the intermediate pressure turbine blades. Discovered in early 2016. The fix wasn't quick. It wasn't cheap. As many as 44 aircraft were grounded at one point because of it, and Rolls-Royce eventually took a hit of at least £1.3 billion because of the program. That's billion, with a B. So when people casually say, the 787 engines are great, well, the GE side of the fleet had an easier ride. The Trent 1000 side spent years digging out of a hole, and that hole is actually the reason the XE exists. You don't redesign a high-pressure turbine blade from the ground up unless something in the original design forced your hand. Myth number 2. An engine upgrade is just some new software and a couple of new bolts. This one drives engineers crazy, because what Rolls-Royce did with the Trent 1000 XE is not a tweak. It's a rebuild of the engine's hottest, most stressed, most complicated section. The redesigned high-pressure turbine blade has a completely new cooling architecture. 40% more cooling flow than the previous version. 40%. That sounds like a marketing number. It's not. It means the blade runs significantly cooler under the same operating conditions, which means it lasts dramatically longer. And let's stop for a second on what a high-pressure turbine blade actually is. Because once you understand it, the whole upgrade makes more sense. Picture a small metal blade about the size of your palm. It sits right behind the combustor, the part of the engine where jet fuel is burning continuously at temperatures hotter than the melting point of the metal it's made from. Yes, you read that right. The blade operates in a gas stream that would melt the blade itself, if not for one thing: cooling. Cold air is bled from the compressor section, routed through tiny internal channels inside the blade, and pushed out through hundreds of microscopic holes on the surface. That cold air forms a thin film over the blade, protecting it from the inferno surrounding it. Now imagine you can route 40% more of that cooling flow through the blade. Suddenly the blade lives longer. Suddenly the blade can survive thousands more cycles before it has to be retired. That's the trick at the heart of the XE. The XE also gets a new combustion system, new fuel spray nozzles, new engine electronic controller software. And then, in Phase 2 of the upgrade, certified in the first quarter of 2026, the entire combustor and turbine interface gets redesigned in the style of the Trent XWB-84. That's the engine that powers the Airbus A350, plus advanced coatings on the combustor tiles, new film cooling on the high-pressure nozzle guide vanes. Even the blade gets a weight reduction in Phase 2. So no, this isn't a service bulletin, this is a generational jump. If you're enjoying the deep dive so far, do me a favor and hit the like button. It tells the algorithm someone cares about real engineering content, and it genuinely helps the channel. Myth number 3. Time on wing is just industry jargon. It doesn't really matter to passengers. Couldn't be more wrong. Time on wing is literally how long an engine stays bolted to the airplane before it has to come off for major shop maintenance. Longer time on wing means fewer disruptions, fewer aircraft sitting in hangars, more flights leaving on schedule, more aircraft available across an airline's network. It's the single biggest operational metric for engine economics. And here's the headline: The Trent 1000 XE delivers up to 3 times the time on wing of the Trent 1010 it replaces. 3 times. Phase 2, when fully introduced, adds roughly another 30% on top of that. Think about what that means for the airlines flying long-haul routes. Fewer engine swaps, fewer spare engine rotations, less money tied up in maintenance reserves, quieter operations behind the scenes. And for you, the passenger? Fewer of those cancellations where the gate agent says, "We're waiting on a part." More of them are engine-related than people realize. Myth number 4. All these durability claims are just marketing. Here's where it gets interesting. The same high-pressure turbine blade design used in the XE is already in service. On a different engine, the Trent 7000. That's the engine that powers the Airbus A330neo. It's been flying with this blade for over 3 years. And what Rolls-Royce found in real-world operations is exactly what they're now promising for the 787. Some A330neo customers have seen their engines stay on the wing nearly 3 times longer than the previous baseline. So the XE isn't a roll of the dice. It's transferring proven hardware from one engine family to another. That's why the company is so confident about the time on wing claims. It's already happening on a sister engine. Comment down below. Did you know the same blade tech was already proven on the A330neo? Because most aviation videos completely skip this part of the story. Myth number 5. If an engine is more durable, it has to burn more fuel. There's always a trade-off. Not this time. The Trent 1000 XE actually reduces emissions compared to the Trent 1010, and the fuel burn stays competitive. The reason this is possible comes down to how modern engineers think about combustion. When your turbine blades can handle higher temperatures more efficiently, you can run the engine at the optimum thermodynamic point for longer without sacrificing component life. Better cooling means hotter, more efficient combustion is sustainable, and the redesigned fuel spray nozzles atomize fuel more cleanly, which means less unburnt material, fewer NOx emissions, less soot. The result is an engine that's more durable and slightly cleaner. Both, at the same time. Myth number 6. The XE upgrade is only for new 787s rolling off the production line. Wrong. This is one of the most overlooked parts of the whole story. Rolls-Royce is retrofitting every single Trent 1010 currently in service. That's the entire global in-service fleet. The plan is for all of those engines to receive the Phase 1 components within 2 years. Rollout completion is targeted for late 2027. The company is doing this through 3 of its global maintenance, repair, and overhaul facilities: UK, Germany, Singapore. They've already increased Trent 1000 supply chain output by 33% in a single year. They've expanded MRO capacity by roughly a quarter, so when you board a 787 powered by Trent 1000s in 2027, there's a very high chance the engines you're flying on have been completely upgraded since they originally rolled out of the factory. That's not how engine programs usually work. Most upgrades only ever land on new builds. This one is different. Quick sidebar. If you're enjoying this, subscribe to the channel. We go this deep on aviation engineering every week. Myth number 7. A bigger fan just means a bigger, hungrier engine. This is one of those intuitive ideas that's almost completely backwards. The Trent 1000 has a 2.85-meter fan. That's roughly 9 feet 4 inches across. It has a bypass ratio of over 10-to-1, the highest bypass ratio of any Trent engine ever built. And here's the trick. Over 85% of the engine's thrust comes from the bypass air, not from the core, not from the burning hot exhaust shooting out the back, from the cold, slow, massive column of air that the fan moves around the outside of the engine core. A bigger fan moving more air at lower velocity is actually more efficient than a smaller fan moving less air faster. That's why modern jet engines look like flying donuts wrapped around a tiny core. The Trent 1000 is basically a giant air pump with a relatively small heat engine in the middle making it spin, and the XE just made that core dramatically more durable. Myth number 8. The 787 has the same kind of engines as any other widebody. This one I love. Because the architecture of the Trent 1000 and the GE GEnx 1B that competes with it is fundamentally different from older widebody engines. Why? Because the Boeing 787 is a bleedless aircraft. Most jets bleed compressed air directly out of the engine to pressurize the cabin, run the air conditioning, de-ice the wings, and start the next engine. The 787 doesn't do that. The 787 is essentially an all-electric airplane. Almost all the systems run on electricity instead of bleed air, which means the engines have to feed enormous electrical generators. The Trent 1000 has to extract up to 500 kilowatts of electrical power from each engine. That's half a megawatt per engine, just to power the airplane. So the XE isn't just a more durable version of an old engine. It's a more durable version of an engine that already had to be uniquely designed to feed an aircraft system, unlike anything that came before it. And here's a detail almost nobody talks about. The Trent 1000 uses a 3-shaft architecture, 3 independent coaxial shafts spinning at different speeds inside the engine. Most engines in this size class use 2 shafts. Rolls-Royce sticks with 3. Why? Because 3 shafts let each section of the engine spin at its own optimal speed. The fan can rotate slowly. The intermediate compressor can spin medium fast. The high-pressure compressor can spin extremely fast, each one in its sweet spot. The result is a more stable operating cycle and a layout that actually works better for a bleedless airplane. So when people argue Trent versus GenX like they're the same kind of engine in different paint, they're missing the point. Internally, these are 2 completely different philosophies of how to build a high-bypass turbofan. Myth number 9. Lufthansa just got an ordinary 787 delivery in late 2025. Nope. Lufthansa is the launch customer for the Trent 1000 XE. The first XE-powered Boeing 787-9, registration DABPT, was delivered to them in early November 2025. That airplane is the start of an entire new chapter for the 787 program. Every airline that takes delivery of a Trent 1000-powered Dreamliner from now on will be getting XE engines from the factory. So if you're flying Lufthansa long-haul on a 787 in 2026 and beyond, there's a real chance you're sitting on the very engine standard we're talking about right now. That's how recent this is. We are watching the rollout happen in real time. Myth number 10. Rolls-Royce is going to give up on the Trent 1000 and let it die quietly. Hard no. People love this narrative because it's emotionally satisfying. The company struggled with the engine for years. Customers got frustrated. Some airlines pivoted to GE-powered 787s. The Trent 1000 backlog shrank to a tiny fraction of the GE&X backlog. So the natural assumption is that Rolls-Royce is just letting the program wind down. But that's not what's happening. The company is actively investing in this engine. They've upgraded supply chain output by 33%. They've expanded MRO capacity. They've launched 2 phases of durability enhancements within roughly 12 months. They've added the total care support package as standard with the XE, which means cost predictability for airlines and a much stronger competitive proposition. Rob Watson, the president of civil aerospace at Rolls-Royce, called the XE a step change in performance. None of that is the behavior of a company giving up. That's the behavior of a company doubling down. Myth number 11. Engine certification is a quick formality once the design is done, not even slightly. The Phase 1 components on the Trent 1000 XE got their first FAA certification in the summer of 2025. The improved high-pressure turbine blades had already been cleared by EASA, that's the European regulator, back in 2024. Anticipating final approval, Rolls-Royce had been quietly fitting the upgraded parts to new-build engines from the start of 2025, before all the paperwork was even closed. Phase 2 certification came in the first quarter of 2026. And here's the wrinkle. Phase 1 required actual flight testing on a 787 because changes that affect aircraft performance at the airframe level need flight validation. Phase 2 was technically classified as a minor modification and did not require flight test, but it still needed coordination between FAA, EASA, and Boeing, because anything that touches a certified engine on a certified airplane has to pass through multiple regulatory frameworks at once. That's why aviation moves slowly, not because the engineers are slow, because the safety net is woven from dozens of overlapping checks and any one of them can hold the whole thing up. Now here's the thing nobody likes to talk about with the Trent 1000 story. The Trent 1000 fleet has surpassed 23 million flying hours on the Boeing 787. It has carried more than 350 million passengers around the world since the engine entered service in 2011. The dispatch reliability of the family, meaning the percentage of flights that depart on time without an engine-related delay, is around 99.9%. Yes, there were durability problems. Yes, the cost was enormous. But the engine never stopped flying. The fleet kept moving. And every one of those flights, every one of those passengers, contributed real-world data that fed back into the design of the XE. That's the part that always gets lost when people talk about engine programs. The engineering doesn't happen in a clean lab. It happens at scale on revenue flights with millions of cycles of real wear and tear feeding back into the next design iteration. The XE is what 23 million flight hours of learning looks like. So let's zoom out for a second. What does the Trent 1000 XE actually mean for the future of the Boeing 787? A few things. First, it gives the 787 program, which has its own ongoing challenges with production rates, quality, and supply chain, a much stronger reliability story going forward. Boeing is also separately introducing higher maximum takeoff weight versions of the 787-9 and 787-10 in early 2026, which let airlines either fly farther or carry more cargo on the same airframe. That's a Boeing structural and certification upgrade, completely separate from the engines. But combine the two, a more durable engine with more capable airframes, and the 787 in 2026 is a meaningfully better airplane than the 787 you boarded in 2019. Same model, same shape, profoundly different aircraft underneath the skin. Second, it changes the competitive picture. The Airbus A350, particularly the A350-900 and A350-1000, has been chipping away at the 787's long-haul dominance for years, partly because some airlines lost confidence in the Trent 1000 reliability story. A solid, durable, lower-emissions Trent 1000 XE pushes back on that narrative. It doesn't mean every airline will suddenly switch sides, but it removes one of the strongest arguments against picking the 787 for new long-haul fleet decisions. Third, and this is where it gets philosophical, it tells you something about how aviation actually progresses. We tend to imagine breakthroughs as flashy unveilings, new aircraft, new shapes, new paint jobs. The reality is that most of the real progress in aviation happens inside metal cylinders that you'll never see, hidden behind the engine cowling, inside the combustor, inside the cooling channels of a single turbine blade you could hold in one hand. That's where the real war is fought. Heat, pressure, vibration, fatigue, a blade that runs 5 degrees cooler, a coating that survives one more thermal cycle, a nozzle that atomizes fuel just a little bit better. Multiply those tiny gains across thousands of engines and millions of flight hours, and you end up with airplanes that are dramatically safer and more efficient than the ones from the previous generation, even though they look almost identical from the outside. Tell me in the comments, when you fly, do you ever pay attention to which engine is on the wing? Because once you start, it's hard to stop. Trent 1000 versus Gen X. Each has its own sound. Each has its own story. Now, to be fair, the Trent 1000 XE doesn't fix everything. Rolls-Royce still has work to do on shop visit capacity in some regions. Some airlines that got burned by the original durability issues remain cautious, and the Trent 1000 backlog has shrunk to roughly 40 of the 1,048 Boeing 787 orders currently on the books. Over half of those 40 are from Lufthansa alone. The reality is that GE's Gen X will probably remain the dominant engine choice on new 787 orders for the foreseeable future. The XE is a recovery story, not a market reversal, but for the airlines and passengers actually operating Trent 1000-powered 787s, and there are hundreds of them in service worldwide, the XE is genuinely transformational. Less downtime, lower emissions, better cost predictability, and a path that takes every existing Trent 1010 engine in the global fleet and walks it through a controlled upgrade over the course of 2 years. That's the part that I think doesn't get enough credit. Not the headline number, not the 40% more cooling flow, not even the 3 times time on wing. The fact that they're committed to retrofitting an entire global in-service fleet on a defined timeline. That's industrial-scale engineering with real airline schedules at stake. And it's quietly happening right now every week, at 3 MRO facilities scattered across 3 continents. If you've made it this far, you're the kind of viewer this channel is built for. Hit subscribe, drop a comment, and if you fly on a 787 in the next year, take a look at the engine on the wing. There's a real chance it's been touched by the XE program, or will be soon. So the Trent 1000 XE isn't really a story about an engine. It's a story about what happens when a program almost fails, gets its lessons brutally and decides to keep going anyway. About a blade that runs cooler so an airplane can fly longer. About a combustor that burns cleaner so the air on a long-haul route is a little less polluted. About a global fleet of engines all moving toward a better version of themselves, one shop visit at a time. The next time you board a Dreamliner, and you happen to be sitting next to a Trent 1000, listen to it for a second. That sound is the result of more than 2 decades of engineering, more than 23 million flying hours of data, and over 1 billion pounds of hard-earned lessons. The aviation industry doesn't always learn quickly, but when it does learn, it learns in a way that ends up under the wing of every airplane you'll ever fly on. And maybe that's the strange beauty of all of this. The best aviation upgrades are usually the ones nobody notices. Quiet, slow, hidden in plain sight. Just metal getting a little smarter, year after year, until one day the airplane you've flown 100 times is doing things it could never do before. And no one ever made a single announcement.